Hello, my name is Adrienne Wallace, and today I'll be discussing Web 3.0 and its relationship to connectivist learning, the next evolution in education. I'll describe Web 3.0 and how it differs from Web 1.0 and Web 2.0. I'll identify Web 3.0's key technical affordances, instructional benefits, and how it empowers learners in a connected, data-driven world. And I'll also explain connectivist learning and how Web 3.0 supports it. Let's begin with the evolution of the web and how it evolved from Web 1.0, which is read-only, static information-based websites, to Web 2.0, read-write, social, collaborative, and interactive platforms, and now Web 3.0, read-write, execute, intelligent, decentralized, and personalized web. Web 1.0, according to CERN's History of the Web, the World Wide Web was invented in 1989 by Tim Berners-Lee as a way for scientists to share information easily. Web 1.0, often called the read-only web, was primarily static. Users could view information, but there was very little interaction. Next came Web 2.0, the social and collaborative web. This stage introduced user-generated content, social networking blogs, wikis, and multimedia sharing. Users could now contribute, comment, and collaborate. Examples were YouTube, Facebook, and Wikipedia. Now we've entered Web 3.0, the semantic and intelligent web, often called read-write execute or semantic web. As Simply Learn describes, Web 3.0 is powered by artificial intelligence, machine learning, blockchain, and decentralization. It focuses on connecting data meaningfully so machines can interpret and personalize user experiences. This web is about intelligence, personalization, and ownership, empowering users with both control and deep engagement. An example would be ChatGPT. Technical features and affordances of Web 3.0. 1. Semantic and intelligent data affordances. Artificial intelligence automates tasks and personalizes learning. An example would be a learning management system that automatically suggests tutorials based on a student's performance on different assignments. 2. Decentralization and ownership gives users control over data and identity. Peer-to-peer collaboration, data privacy, and security. Learners and educators can own and manage their digital credentials. 3. Artificial intelligence and automation. Adaptive learning paths and AI tutors and assistants. Adaptive learning paths that adjust difficulty based on performances, and AI tutors and assistants for real-time feedback. 4. 3D and XR environments. Immersive virtual learning. Web 3.0 integrates XR technologies, virtual, augmented, and mixed reality, creating opportunities for global collaboration in shared virtual spaces. 5. Interoperability and connectivity. Internet of Things and smart systems. APIs and linked data allow learning platforms, portfolios, and analytic tools to share insights. An example would be a student's progress data from Nearpod CodePen and the school's LMS synced together into a single dashboard. Social and community, pure validation and connectivist learning, pure validation of contributions and digital citizenship development. Instructional benefits of Web 3.0, personalized and adaptive learning, artificial intelligence and data analytics tailor instruction to each learner's pace, style, and needs. Verifiable credentials and digital portfolios, blockchain credentials let students securely store and share their achievements across schools and platforms. Enhanced collaboration and global connectivity. Web 3.0 supports decentralized collaboration. Students and educators co-create, share, and peer review work in connected networks. 2. Verifiable credentials and digital portfolios. Blockchain credentials let students securely store and share their achievements across schools or platforms. Next, enhanced collaboration and global connectivity. Web 3.0 supports decentralized collaboration. Students and educators co-create, share, and peer review work in connected networks. 4. Immersive and hands-on experiential learning opportunities. Through AR, VR, and 3D web technologies, students engage in hands-on simulations and problem-solving environments. 5. Data-informed and transparent assessment. Semantic data and analytics enable teachers to analyze engagement data to identify students needing additional support. Equity and accessibility. AI and semantic search make learning materials more contextual and accessible to diverse learners. Text-to-speech, translation, and adaptive interfaces ensure inclusivity for all students. In summary, together these affordances create a smart, connected, and inclusive educational ecosystem where learning is dynamic, adaptive, and lifelong. Let's shift to connectivist learning theory, introduced by Joyce Simons in 2005 and Stephen Downes in 2007. Connectivism argues that learning is not just an individual process, but occurs across a network of people, technology, and information. Learning is the ability to navigate, connect, and create knowledge within those networks. Emphasize connection, collaboration, and digital literacy. In today's digital classroom, students connect through platforms, collaborate in real time, and co-construct understanding through digital tools, hallmarks of connectivism. Principles of connectivism. Learning is distributed across networks. An example is a student can learn by collaborating in online communities, watching YouTube tutorials, and asking AI chatbots, building understanding through a network of resources. Capacity to know more is more important than what is currently known. In the digital age, information changes rapidly. The ability to find, evaluate, and apply new knowledge is more valuable than memorizing static facts. Nurturing and maintaining connections is crucial for learning. Continuous interaction with networks keep knowledge current and relevant. An example, educators joining professional learning networks or attending webinars to stay up to date on digital tools. Decision making is a learning process. Choosing what to learn, where to find it, and how to apply it is a critical skill. Example, deciding on which AI tool best supports lesson planning or student assessment in your classroom. Learning may reside in non-human appliances. Knowledge doesn't just live in people, it also exists in database, algorithms, and AI systems. An example, using AI tutors or learning management systems to adapt to a student's behavior over time. Accurate, up-to-date knowledge is the intent of learning. Effective learners are those who can continuously update their knowledge through connected networks. In summary, connectivism views learning as the ability to connect, navigate, and make sense of information in a constantly shifting digital landscape. How Web 3.0 and connectivist learning intersect? Both emphasize networks and connection. Together, both enable a global learning ecosystem where students, teachers, and data sources communicate seamlessly. Personalized and adaptive learning. An example, an AI-powered coding tutor suggests next-level exercises based on each student's performance. A direct link between theory and technology. Decentralized knowledge creation. Connectivism sees knowledge as distributed across networks, not owned by a single source, and Web 3.0 uses blockchain and decentralization to mirror that idea. Collaboration and co-creation of knowledge. Connectivist learning thrives on collaboration and dialogue. Web 3.0 supports this through 3D virtual environments, blockchain-based communities, and AI collaboration tools. Continuous lifelong learning. Connectivism emphasizes that learning never stops. Web 3.0 technology supports lifelong learning through data-driven learning journeys. Empowerment and digital identity. An example, a student's blockchain verified digital portfolio can follow them across schools, jobs, and professional networks, reflecting connectivism's emphasis on self-directed learning and connectivity. From consumption to participation, Web 3.0 and connectivism focuses on creating and contributing within learning networks. Students become co-creators of knowledge while learning through shared databases. Instructional benefits of Web 3.0, personalization and differentiation through AI. Teachers can use AI dashboards to track students' progress and intervene more effectively. Learner autonomy and ownership. Blockchain credentials let students securely store and share their achievements across school platforms. Enhanced collaboration and global connectivity. Web 3.0 supports decentralized collaboration. An example, students in different countries can work together in a shared 3D design lab. Immersive and hands-on experiences. Through AR, VR, and 3D web technologies, students engage in hands-on simulations and problem-solving environments. Data-informed and transparent assessment. Semantic data and analytics enable teachers to make evidence-based instructional decisions. Example, teachers analyze engagement data to identify students needing additional support. Equity and accessibility. AI ensures inclusivity for all students using text-to-speech, translation, and adaptive interfaces. Conclusion and reflection. Web 3.0 transforms learning into an intelligent, connected, personalized experience, combines semantic web, AI, and decentralization with network connectivist learning. Educators shift from content deliverers to learning facilitators. Students build knowledge networks through collaboration, creation, and sharing. Promotes autonomy, critical thinking, and lifelong learning. Calls for student-centered, adaptive, and ethical learning environments that prepare learners for a global, evolving digital world. Thank you.